Hello, welcome to Leetcode 75 day 7, and we're doing find peak element. This is 126. So a peak element is an element that is strictly greater than its neighbors. Given a zero index integer array nums, we have to find a peak element and return its index. If an array contains multiple peaks, then we have to return the index to any of the peaks. You can imagine that if the number of the element, or if the index -1, which is the last element in the array, is equal to nums of uh, like the length of the array, which is -infinity. So in other words, this means that an element is always considered to be strictly greater than a neighbor outside of the array. And we have to write an algorithm that runs an O of log n time, and that kind of points to like a binary search solution, but we can talk about that later. So for example 1, you have 1, 2, 3, and 1. So the index that you return is 2, and 3 is the peak element. And for the second example here, there's two different peaks, which is at index 1 and index 5, which is 2 and 6. So that means that we can return either 1 or 5, since those are the peak elements in their local space. So the constraint that's very helpful here is that the nums of I is never going to be equal to the element to the right of it. And this means that we'll always find a peak element. So the way we can visualize this is by using the concept of slopes here. So we need to think about a ascending slope and a descending slope, or declining slope. So this means that we need to always be on this, like we need to narrow down our search from looking at an ascending slope, and then we need to go back to a descending slope to find where that peak can be. And when we're using binary search, so we have our high, our low, and our high, which are like our pivotal elements that we're going to keep shifting around to like decrease our search window. So we need to make sure that we're trying to essentially make the low pointer and the high pointer be equal to each other, which means that we found the peak. So every time that we're on the ascending slope, we're going to set our high pointer to be equal to the mid plus 1. Every time we're on a declining slope, we're going to set our low to be equal to the mid, so that we can eventually set the low and the high pointer to be equal to each other, and we're like kind of seesawing on the declining and the ascending slopes. So the way that we can implement this is we can have our two pointers, low and high, and then we're going to say that while low is less than high, and then we can return either low or high in this case. We'll return low. We're going to say that mid is equal to low plus high divided by 2, and we're going to say that if mid of nums of mid is less than nums of mid plus 1, that means we're on a declining slope, or that means we're on a ascending slope. So that means that we need to our current number is less than the number to the right, so that means that we're not at a peak right now. So that means we need to set our low pointer to be equal to mid plus 1, so that we can be at the peak. And then when we're on the declining slope, we need to set our high to be equal to our mid, so that we can decrease the search window and eventually hit the peak. And that should be the solution. Declining slope. Oh. Maybe I might have flipped these two. Oh, this is not right. And that's gonna time out. There you go. Okay. So if we think about it this way, we're gonna have our low pointer set here, our high pointer set here, and then our mid is gonna be the floor of this, so it's gonna be at 2, or it's gonna be at index 1. So we're gonna see that this number is gonna be less than 3. So we need to move our low pointer up to 3, or index 2. And then when we have 2 and 3 set to be our low and high, we're going to go through the array and, uh, 2 plus 3, 5 divided by 2, 4 divided by 2 is going to be 2, I believe. That's going to be 2. So it's going to be 0, 1, 2. So it's going to be at 3. So our mid is at 3. And the number here is actually greater than the one to the right, which is 1. So we're going to set our high to be equal to 3. And this condition doesn't work anymore, so we have to return low or high, and that's going to be 3. Even if we used high, it would still work. Because we're trying to make it so that these two numbers are eventually equal to each other. And yeah, that's the solution to this problem. Thank you.